This video will cover notes on using factoring to solve equations. So far, we've factored expressions, so there was no equal sign. We were just figuring out how to undistribute. But now we're going to look at how we're going to use factoring to solve equations. So before we go into that, we want to talk about if we want to find two numbers whose product is 0. So if you think about two numbers, when I multiply them together to get 0, you might think of like 3 times what would equal 0? Well, it would have to be 0. Or 0 times what equals 0? Well, really 0 times anything could be 0. So we could say -5 really times 0. Or even we could say 0 times 0 is 0. So if I want to come up with two numbers whose product is 0, one of them has to equal 0. So here we have what's called the zero product property. So product meaning multiplying. And it's a property that if I have two things that are being multiplied, so A times B, so that's AB means A is multiplied by B. If that equals 0, then A equals 0, B equals 0, or both of them have to equal 0. All right, now, when we're factoring, remember we are finding, we're factoring a polynomial, so we're undoing multiplication. So that is, if we look at example 1, I already have a factored polynomial for you. So I have x minus 3 times x plus 2. So remember, to factor is to see what times what equals that number. All right, and notice here that I have equaling 0. So if we apply this zero product property, you can kind of think as this x minus 3 is like A, and then x plus 2 is like B. So then A times B equals 0. So if in order to solve, this is now an equation because we have an equals 0 here, we need to figure out what values for x would make this equation equal 0. All right, so if you see that x minus 3, that whole thing could equal 0. So x minus 3, remember that is an entire factor, so that's like A. That could equal 0, as well as the other factor of B, which is x plus 2. That could also equal 0 in order to make this whole thing equal 0. All right, so now if I want to find the values of x, now all I have to do is solve for x. But you have two equations, which is fine. So if I solve here, you add 3, so that means x could equal 3. So in this problem, if x equals 3, then the whole thing would equal 0, and that makes sense, because if I put 3 here, then 3 minus 3 equals 0. Doesn't matter what's sitting here, because 0 times anything is 0. Now, that's not the only possibility. The other possibility is if x plus 2 equals 0. So then, if you want to figure out what x is, all you have to do is subtract 2. So x could also equal -2. And so to show you on that one, if x was -2, then -2 plus 2, that would go away to 0. And again, doesn't matter what's sitting here. 0 times anything would equal 0. Okay? So all it's asking for, what possible values of x would make this whole thing equal 0. And we found two possibilities, -2 and 3. Now when you write your final answer for this, what I've written is fine. You can write two separate examples of x, but you can also write them together as one. So I would write x equals, and we typically go from smallest to biggest. So my smallest value of x was -2. Then all you have to write is a comma, 3. So x equals -2 and 3. For those two x values, this whole thing would equal 0. That's really all we're doing. Okay, so let's try example 2. Find the possible x values if 7x minus 1 times 2x minus 3 equals 0. So again, either 7x minus 1 is equal 0 or 2x minus 3 equals 0. So all we do, we take those two separate factors, those two things in parentheses, and set them equal to 0. So we have 7x minus 1 could equal 0, or 2x minus 3 could equal 0. Now we just simply solve for x in both equations. So add 1, and we get 7x equals 1. Then divide by 7, and we get x equals 1/7. So that's one possibility. The other possibility in green, 2x minus 3 equaling 0. I add 3, so 2x equals 3. Divide by 2, and you get 3/2. So then to write my final answer, you would say x x equals, the smaller one is 1/7, and then the larger one is 3/2. So those are the two numbers that would make that equation equal to 0. Okay, we're going to try one more for example 3. Find the possible values of x for this factor. Now, notice in example 1 and 2, I just had the two parentheses. Now, in example 3, I've got this negative 4x sitting out front. That does not have parentheses around it because it's a monomial. It's just one term. See, x plus 9 is a binomial, so that's why we have parentheses around it. Same with 5x minus 1 is a binomial, so we have parentheses. But notice that negative 4x is still considered a factor. This would be like a times b times c equaling 0. Okay, so we have three separate factors. So again, any of those could be 0. A could be 0, and it would not matter what b and c are. Same with b, same with c. So no matter how many factors you have to set each one equal to 0. So my first would be negative 4x equals 0. Then you would have x plus 9 equals 0. And then finally, you would have 5x minus 1 equaling 0. So you would have three possibilities of x equaling 0. Now, negative 4x equaling 0, that's really easy because negative 4 times what equals 0? Just 0. Okay, so if x was 0, this whole thing would equal 0, which is fine. Then the next one, x plus 9 equals 0. That's easy. That would just be negative 9. And then 5x minus 1 equaling 0. If you add 1 first, then divide by 5, then you get 1/5 as x. So now to write my final answer, I'm going to say x equals, I'm going to go from smallest to largest. My smallest number is actually negative 9, then 0, then the fraction 1/5. So I have three possibilities of that equaling 0. Okay, now these first three examples were already factored for you. We were just figuring out how to solve with a factored answer. So now what we're going to look at in the last three examples is I'm not going to give you a factored equation. You're going to have to factor it yourself. So these are steps to solve a quadratic equation. Now, quadratic we haven't really learned yet. You may have learned it a little bit in physics, but just to show you the standard form of a quadratic, it means x is squared, okay? Then plus bx plus c. We've seen this before, ax squared plus bx plus c, but now it's a quadratic equation. Now, remember at the beginning, we had to equal, every single problem we are equaling 0. So we have ax squared plus bx plus c equaling 0. If we equaled any other number, then we cannot do this. It has to equal 0. So here's the steps. Move all terms on one side of the equation in proper descending order equal to 0. That's essentially just that, ax squared plus bx plus c equals 0. Then we're going to factor. Then set each factor equal to 0, just like we did in the first three examples, and then write your answer. Okay, so example 4. Solve this equation, and first of all, we want to make sure that it's in standard form, and it already is. Ax squared plus bx plus c equals 0. So it's in standard form, so now our second step is to factor. So just to kind of review with factoring, first of all, notice that a is 1, and so that's really nice. If a is 1, then that's when you can use that shortcut, but you can only do that if a is 1. So let's review how to do that shortcut. So we still do a times c, which is negative 21, and we factor negative 21. Now remember, we're going to leave off the negative for now. We would say that's 1 and 21 and 3 and 7. Now since 21 is negative, that means we're going to be subtracting in order to get our b, which in this case is a positive 4. So I want to subtract to get a positive 4, so we have to figure out which factor is negative. 121, that's not going to make 4, but 3 and 7 will, by taking a positive 7 and a negative 3. So negative 3 plus 7 does equal positive 4. So since a is 1, and again, only if a is 1, now I don't have to do the factor by grouping. My two answers are negative 3 and positive 7. So this factors into x minus 3 times x plus 7 and then it's still an equation, so it still equals 0. Now we have exactly what we did in the very first 3 examples. So now after we factored, the third step is to set each factor equal to 0, just like we did. So that would mean x minus 3 equals 0 and x plus 7 equals 0 and solve. So now that's very easy. You just add 3 and subtract 7 from 0. So my final answer is -7, 3. Okay, so we're just adding one more step in. All right, so example 5. So this is an example where we do not have standard form. Also notice that we're not equal to 0. So this is where in step 1, it says to move all the terms on one side of the equation. We want to be equal to 0. And then we also want to be in standard form, so that is descending powers. Okay, so notice we have the squared first, and then the cubed, and then over here we have the power of 1. So I'm going to do 2 steps in one. I'm going to write in descending power, and I'm also going to move this 45x. I'm going to subtract it from both sides, because I want nothing over here. I want 0 over here. So that means I'm going to subtract 45x. So now I'm going to take those 3 terms here and write them in descending order. So, or the exponents in descending order. So that would be 6x cubed first, then 21x squared, then minus 45x equals 0. Okay. Now, this one, then the last one was very easy. We just had to factor. It was very, very easy. But this one, now we're going to have to look at factoring completely, which we did in the last lesson. So factoring completely means you want to look for a GCF first and take that out. So this one does have a GCF. If you look at 6, 21, and 45, the common factor there would be 3. And also, if you see there's x cubed, x squared, and x, so an x also comes out. So we're going to factor out a 3x first and see what we have left. That would be 2x squared plus 7x minus 15 equals 0. All right, notice I still have equals 0 on the other side. Okay, so now that I've taken the GCF of 3x out, look at what's inside the parentheses. Now that's a trinomial that I can factor, and I'm going to factor that using the AC method. Okay, so using the AC method, remember we want to take A, which is 2, and B, which is, C, which is negative 15. So A times C is 2 times negative 15, which is negative 30. And we want to factor that. So that would be 1 and 30, 2 and 15, 3 and 10, and 5 and 6. Now let's look and see what the B is. The B is positive 7. So I want to, since A times C is negative, I want to actually subtract to get a positive 7. And so I see that would be 3 and 10, where 3 is negative. So negative 3 plus 10 would make a positive 7. All right, so now if I rewrite this, this would be, 3x, and remember we have to factor this by grouping because A is not 1, A is 2. So we cannot use the shortcut like we did in example 4. So then we're going to factor by grouping. So what that means is we're taking that 7x and splitting it into 2 terms. So remember to do this, we want to keep the 2x squared, the first thing, the same. Now the 7x splits into negative 3x, we're going here, plus 10x, and then the minus 15 also stays the same. We're still equal to 0 here. Okay, so this 3x out in front, that GCF, it's just along for the ride, so just keep it there. And now we're going to factor by grouping, so because we have 4 terms. So then look at the first 2x squared minus 3x, that has a common factor of x, times 2x minus 30. Then 10x minus 15 has a common factor of 5. When you factor out that out, you get 2x minus 3 as well. And that is still, equal to 0. Okay, I know there's a lot of steps, but we've already learned how to factor. So everything so far really is not new. Okay, so now we have one last step, and so the 3x again stays out front, And then we have the 2x minus 3 as a factor. And then what's left over was x and plus 5. So that is a factor. So now we have factored completely. So now that we've factored completely, the last step's really easy. I'm equaling to 0, and I have 3 separate factors. So those 3 separate factors, I'm going to write out separately and say those are equal to 0. So 3x equals 0, 2x minus 3 equals 0, and x plus 5 equals 0. So when I solve, you get x equals 0. X equals, if you add 3, then divide by 2, you get 3 halves, and x equals negative 5. And again, to write your final answer, write it all in one, so the smallest negative 5, 0, and then 3 halves. That is your answer for example 5. And sorry I didn't give you a whole lot of room for that. Okay, now for the final example. Okay, again, notice that this is not equal to 0, so you cannot solve by factoring unless your answer is equal to 0. Okay, so the first thing that I'm going to do is set this equal to 0, so I'm going to subtract 32. So then you get 50c squared minus 32 equals 0. Now notice that we do not have like the ax squared plus bx plus c. We don't have 3 terms, which is fine. We're just going to factor like normal. And so if you have a binomial, you do not factor by the AC method. First is that you look for a GCF. So you do have a GCF with 50 and 32. The GCF is 2. So then that would be 25c squared minus 16 equals 0. And so if you have a binomial after you've factored out your GCF, then the only other way that you could factor this is if it was a difference of squares, which this is. 25 is the square of 5, then c squared is even, 16 is the square of 4. So, and we're taking a difference. So this is a difference of 2 squares, so then we would factor like that. So 25c squared would be 5c minus 16 would be 4, and then you'd have 5c plus 4 equals 0. So now that we've completely factored that, now we can set that equal to 0. Now notice that 2 is a factor. So if we continue on like we've been doing, 2 equals 0. Like if we have 3 different factors here, 1, 2, 3, then you would say 2 equals 0, but that will never equal 0, so that's not really going to factor into this. Okay, so then you have 5c minus 4 equaling 0, and 5c plus 4 equaling 0. So then add 4. 5c equals 4, divide by 5, and you get 4/5. Same thing over here, but I'm going to subtract 4. So c equals negative 4/5. Now to write this, you could write negative 4/5, comma, positive 4/5. But since they're the same number, but just positive and negative, you can actually do a quick little shortcut by writing plus, minus, and then 4/5, and that will cover you. Okay? So that is how you solve equations using factoring.